Which place has a value that is 10 times greater than the place of the underlined digit? Okay, this is a place value problem, so we're going to bring out a place value chart. And I'm not sure what happened here. Let's try that again. All right, that's better. If you don't have a place value chart, you can copy this one. And we're going to use our place value chart here to establish a pattern that's going to help us solve this problem. I'm going to start at my ones place. If I move one place to the left, I'm going from ones to tens. Now think about this. It takes 10 ones to make 10. So our tens place is 10 times greater than the ones place. So if I move one place to the left from my ones to the tens, that place will increase 10 times. It will be 10 times greater. So we'll put 10x to represent 10 times. Now, if I move from my tens place to my hundreds place, think about this. It takes 10 tens to make 100. So my hundreds place is 10 times my tens place. So again, if I move one place to the left, the value of that place will increase by 10 times. All right, let's move from the hundreds place to the thousands place. Again, it takes 10 100s to make 1,000. So we've increased again 10 times. And you've probably figured out now that this pattern will continue on. It takes 10 1,000s to make 10,000. It takes 10 10,000s to make 100,000. So each time we move left, we're increasing the value of that place by 10. Okay? If we go from our 100,000s to our millions place, it takes 10 100,000s to make 1 million. So again, we've increased our place 10 times by moving one place to the left. All right, and this pattern would continue. We could go on up into the billions and the trillions, and each time we move left one place, that place increases, or its value increases 10 times. This also works with decimals, and we'll do an example of that here in just a minute. Now, let's see how we can take what we did right here, take our pattern that we established, and how can we use that to solve our problem. All right, the problem is asking me to find the place that is 10 times greater than the place of the underlined digit. Well, my underlined digit here, this 8, if I look at my place value chart, I can see that it's in the hundreds place. Okay. Now, using my pattern that I established right here, I know that if I move one place to the left, that place will be 10 times greater. So we'll do just like we did on our place value chart. We'll just make a little arrow this way, and we'll even label it 10 times, or 10x. Okay. And that tells us that this place, where the 6 is in this particular number, is 10 times greater than this place. Now, what place is this? Well, if I look at my place value chart, I can see that that would be the thousands place. So in this number, the place that is 10 times greater than where my underlined digit is would be the thousands place. All right, to summarize what we just learned, as I move left in a number, each place increases 10 times. All right, let's do another problem, and we're going to apply this concept in reverse. All right, this problem is asking me which place is 1/10 of the place of the circled digit. All right, let's go back to our place value chart, and let's see if we can establish a similar pattern to what we did before. Now this time we're going to start over here in our millions. Now, if I go from my millions place to my hundred thousands place, okay, 1 million is made up of 10 hundred thousands. So if I move from my millions place to the right, I decrease the value of that place by 1/10. So 1 millionth, or the 1 millionths place is 1/10. Let me correct myself. The hundred thousands place is 1/10 of the millions place. Let's continue on. If I move from my hundred thousands place to the right, it takes 10 thousands to make 100,000. Okay. So the 10 thousands place is 1/10 of the 100 thousands place. So as I move to the right, each place to the right is 1/10 of the place to its left. So I'm decreasing by a factor of 1/10 each time I move one place to the right. You can probably see this most clearly when we get right down here into the tens and the ones place. Very easy to understand that 1 is 1/10 of 10. Okay. Now let's go ahead and let's apply this concept to solving our problem. All right, it's asking me to find the place that is 1/10 of the place of the circle digit. So I come here to the 8, that's my circle digit, and I know from the pattern I established down here that each time I move to the right, the place to the right is 1/10. So if I look at my number line, or I'm sorry, if I look at my place value chart, I can see that this 3 right here would be in the 10 thousands place. So the 10 thousands place is 1/10 of my circle digit. All right, so to summarize what we've learned, the place to the right is always 1/10. And the place to the left is always 10 times greater. And I've got a little, just kind of a little mnemonic device, something to help remember that. I call it an arrow ball. And an arrow ball just looks like this. Just draw a little ball. And we have an arrow going out to the right, which I label 1/10. And we have an arrow going out to the left, which I label 10x. And the arrow ball just helps me to remember that if I move one place left, that place increases 10 times. If I move one place to the right, then that place increases to 1/10 of the value. All right, let's do one more. All right, this problem, when you first look at it, it looks like the others that we did. But if you look just a little bit closer, this time we've put a decimal in here. It doesn't change anything. We'll still work it the same way. Now in the place value chart, I've gone ahead and introduced a decimal portion, the decimal side here. So we've added tenths, hundredths, and thousandths. But our pattern still applies. If I move one place to the left, in this case from the thousandths to the hundredths, then the value of that place increases 10 times. It takes 10 1/100ths to make 1/10, So we've increased 10 times. It takes 10 1/10ths to make one whole. And we could continue that on all the way across just like we did before. All right, and likewise, if I move one place to the right, and I could start anywhere, we'll start at our tens place here. One place to the right, the value of that place decreases to 1/10 of the original value. So ones place is 1/10 of 10. If I move to the right, the tenths place is 1/10 of the value of the ones place. Moving to the right again, the hundredths place is 1/10 the value of the tenths place. And then finally, the thousandths place is 1/10 of the value of the hundredths place. All right, so how do I use this to solve my problem? Well, which place is 1/10 of the place of the circled digit? Well, I'll go to the place where my circled digit is. It could be an underlined digit, or they maybe have a blue digit or something like that. But since I'm trying to find the place that's 1/10 the value of this place, I'm going to go to the right. One place decreases the value to 1/10. Okay, so my 7 right here, if I look at my place value chart, moving 3 places to the right from my decimal, I can see that that 7 is in the thousandths place. So the place that is 1/10 of my circle digit would be the thousandths place. Make sure you include the TH there. All right, so remember, when I move to the right one place, my value always decreases by a factor of 1/10. If I move to the left, the value of that place always increases 10 times. Have a good day.